alien reacts.
Fever feels bad, so we take medication to suppress it. But is this a good idea? It turns out fever is one of the oldest defenses against disease.
Oldest
What exactly
defenses
is it?
against
How does
disease.
it make your immune defense stronger? And should you take a pill to combat it?
That's the question. Should we stop a fever?
The heat of life. On Earth, life is able to thrive between the extremes of -10 degrees Celsius in deep, cool pools and 120 degrees Celsius in thermal vents. Step outside this range and die. Every
Biology.
animal or microbe has a temperature range that's ideal and one that's stressful.
Oh, this is interesting. So, fascinating to see the different temperatures that species live in. But we all live in a range that's okay for biology. Fascinating.
But survivable for a while. Your ideal temperature is where your cells work best, where their internal machinery is the most efficient, and the animal as a whole the best adapted to its niche. Humans are warm-blooded animals, and our bodies expend
we're
a lot
lucky.
of energy to keep us around 37
Oh, wait,
degrees
am I
Celsius
one?
or 98.6 degrees Fahrenheit. Which seems wasteful, but this may actually be a defensive adaptation. Our temperature makes
Oh,
us almost
really?
entirely immune to one of the worst killers and parasites, fungi. Most colder animals and their insides are infected by them, but you
Oh,
are
wow.
just too hot. Which brings us to fever.
I didn't know cold-blooded animals were infected by fungi. We are lucky. The Last of Us.
For any microbe that wants to infect you, your body is a world they want to conquer. Fever is defensive climate change, pushing an invader outside its ideal temperature range and making the world horrible. It evolved at least 600 million years ago and is widespread. Most animals increase their core temperature when they're sick. Fish swim into warmer waters, lizards bathe in the sun, bees heat up the air inside their hive. But
Now, isn't that fascinating? Animals who don't produce a fever themselves, they go into warm climates to basically do something called a behavioral fever. It's just amazing that things like that can persist as evolution progresses. It just is baked into them. They just know what to do. Crazy.
you, warm-blooded mammal, you have way more drastic options. Let's make you sick and see what happens. When your blood turns into lava,
Ooh.
you're invaded by bacteria and viruses at the same time. The invasion is powerful and you need to slow it
Bacteria
down as fast as possible.
and viruses.
Fever is part of your first line
Immune
of
system.
defense, triggered by a diverse group of chemicals called pyrogens, the creators of heat. They float away from the battlefield and pass right into your brain, where specialized receptors pick them up and crank up your internal thermostat. First, you begin to shiver. Your skeletal muscles contract really
Shivering,
quickly, which
okay.
generates a lot of heat in your core. At the same time, usually the blood vessels near your surfaces contract and prevent heat from escaping through your skin. Your skin cools down while your insides burn.
So your skin becoming cool traps the heat in your body. That was always so confusing. Why exactly do we become cold when we have a fever and our internal temperature is so hot? That makes sense now.
Fever is a
Interesting.
systemic body-wide response and is a serious energy investment for your body. You burn about 10% more calories to stay alive for every degree centigrade your body temperature rises. Fever is also
That's
a
a lot.
strong order to lay down and rest, to save energy and give your immune system time to fight. Back to the battlefield. When the bacteria entered your body, they tried to be stealthy, but now
Haha,
they've
that's not
switched into high
stealthy.
production mode. Their goal is to multiply as fast as possible, which means they need a lot of resources and are highly stressed. Imagine running a marathon while eating a succulent Chinese meal and giving birth. The last thing bacteria need right now is more stress.
I love these analogies. Only Kurzgesagt does this. I mean, they just, like, what a great visual.
So your immune system tries to stress them out as much as possible by ordering inflammation, which floods the battlefield with fluids, attack proteins, and soldiers. Pretty stressful. Fever is even more stress. For the bacteria a moment ago, the temperature range was pleasant. Now the world burns. Heat can cause their organs to break and the membranes to rupture, damage their DNA, and diminish protein production. They are seriously suffering.
It's also fascinating how protein production, like they're hijacking our cells. It's almost as if like you had a factory and then a bad organization came over and hijacked that factory. And then that factory was used to build more of itself. And then it proliferated and took over more factories and hijacked them. That's what's happening inside our cells. It's crazy.
From the heat. Why doesn't this affect your cells? It does. All of this is stressful for your cells too. Virtually every system and organ of your body works worse during fever, except one, your immune system. Neutrophils are recruited faster. Macrophages and dendritic cells are better at devouring enemies. Killer cells kill better, and so on.
Okay, let's try another analogy. So imagine you have an army, right? And you guys go to the desert, and then everyone struggles, except you have a few people who have like adapted to the desert and are super good, and then they go and decimate the other military. That could be kind of an analogy. Or maybe I'm just...
And fever animates your immune cells to gobble up the critical resources your enemies need, like iron, glucose, and glutamine, turning the battlefield into a food desert. The viruses that infected millions of cells are doing even worse because they're also very sensitive to heat. For example, the rhinovirus that causes the common cold can only infect your respiratory tract because it is significantly colder than the rest of your body, even without fever.
Oh, that is
fascinating.
fascinating.
It's also really bad for the millions of cells that are infected by viruses at this point. They are working super hard producing viruses, which is pretty stressful. As the heat becomes too much to bear,
It's so sad. Our body is producing the viruses that are killing it. What a crazy thing.
the super stressed cells panic. As their internal machinery is breaking and failing, they quickly produce billions of heat shock proteins, or HSPs, that start repairs,
Heat shock
keeping
proteins.
them alive.
Joe Rogan talks about those. When you go into a sauna, it must also help with heat shock proteins.
But this is a trap. Even your healthy cells produce HSPs to deal with the heat, but if a cell makes too many of them, this means it's more stressed than it should be.
Uh-oh,
And if it's
don't produce too
stressed,
many.
Something is wrong, and it should be killed. So your natural
Oh,
killer
poor
cells
cell.
and killer T cells are activated and attracted by HSPs and start killing infected cells and all the viruses inside them.
It was just doing its
By
job.
trying to protect themselves, infected cells are calling out to be destroyed. But if fever is such an effective weapon, why don't your enemies adapt to it? How is it still viable in so many different animals after hundreds of millions of years?
That's a good
A
question.
wild reason is that fever actually might outsmart evolution. If your enemies survive fever long enough, natural selection changes them. The individuals that are better suited to deal with heat reproduce more. After a few days, they've adapted. But this becomes a handicap because the next step is to infect new victims in new bodies, and now healthy humans are too cold for them. Not impossible to infect, just harder. And the heat-resistant microbes now compete with their cousins that like it colder and have an advantage infecting healthy hosts.
That is brilliant. Biology is so freaking cool.
This creates an evolutionary dilemma without a perfect solution. To circumvent this, serious pathogens like measles use hit-and-run tactics. The measles virus is the most infectious right before your fever hits with full force. It's brutally beaten back once your full immune response shows up, but by then, the damage is done. Fever is an effective part of the puzzle of your immune system, helping to attack and stress your enemies from as many angles as possible. But if fever is so great, why do we stop it when we're sick? Should you fight fever with medications? We think it's normal
That's a
to
good
have
question.
magic pills, but relatively harmless over-the-counter pain medication like aspirin or ibuprofen only became cheap and widely available in the last century or so. Going to a pharmacy to get something for your headache is extremely new in human history.
Yeah, evolution has been going on for billions of years, and yet in the past 100 years we've been able to do some things.
Pain feels bad, so we've gotten used to stopping it when we feel it. If you're sick, you're supposed to feel a reasonable amount of pain, so you lie down and save energy. This is not a bug, but a feature of your immune system.
Yeah,
But
how
pain
many
and
other
fever
things are like
closely
that?
connected, and over-the-counter pain medication like ibuprofen and paracetamol also work against fever. Especially in children, fever is often suppressed by worried parents or doctors, sometimes because they think fever itself is the disease, or they're worried that it can do long-term harm. In general, it's fair to say
People
that for
do
temperatures below
over-worry.
40 degrees Celsius or 104 Fahrenheit, fever is not dangerous and doesn't need to be treated. Of course, there are also
Let it
patients
do
that should
its
not
thing.
have fever, like pregnant women, seniors, and
Oh.
seriously weakened patients. For them, the extra
Yes.
stress may be dangerous. Fever over 40 degrees Celsius is dangerous to anybody because it's most likely caused by your internal heat monitor failing. Things get more complicated in serious disease territory. We also have evidence that for some diseases like influenza or chickenpox, anti-fever drugs do not help you to heal faster. But we're also running into ethics problems here that make clinical trials difficult. In one study, doctors gave strong anti-fever treatment to
This reminds me of Purdue, you know, the pharma company that pushed the whole campaign of no one should experience pain. Pain is important. It's how you understand what you need to do. There's a girl who she was born without pain receptors. She puts her hand in the oven, picks up something, holds it, and gets insane burns. We need a feedback loop to tell us when something's bad, and there's got to be reasons for all this stuff.
critical care patients, but had to stop after mortality shot up. Overall, we have strong indications that more people may survive serious infectious diseases better with a fever. And there is very little clinical evidence that stopping fever leads to better health outcomes. But there are important exceptions like neurological injuries and stroke. We definitely need a lot more research. So should
Agreed.
you fight fever? Well, speak to your doctor and don't listen to internet videos. But this decision is really about payoffs. If a fever is not dangerously high and you can bear it, you're supporting your defenses and may even get healthy a bit faster. But if you feel really bad and are healthy in general, taking a pill against pain and fever will make you feel better quicker at the cost of a slightly less effective immune defense. However you decide, the next time you're burning up and feeling bad, you can rest easy in the knowledge that your enemies are having a much worse time than you. It's thanks to
When you think about it, it's kind of obvious, right? Let your body do its job. But if things progress past what it can do, that's when we should use modern medicine. But the body can heal a lot of things on its own. It's been doing it for our entire evolution. Keep your curiosity alive.